just like to welcome everyone to the ilifu online training session today. So this will be a basic training session. So this is aimed more for new users and users who haven't had a lot of experience with the ilifu research facility as of yet. So my name is Jeremy Smith. I work at IDIA with the ilifu cluster. So I'll be starting the online training and cover the first couple of topics, and then my colleague Jordan Collier, who is also visible in the video at the moment. So Jordan is going to help me, and he's going to cover a number of topics later in the training session. So the training session is expected to be about 40 minutes, and then we have set aside time at the end of the training session for questions. So if you have anything, perhaps hold your questions off during the session and then raise them at the end. And then just to make a note that, so this is basic training, and then we're going to cover more advanced topics in 2 weeks' time, also over Zoom. So just in terms of the topics that we're going to cover, we're going to go through the different support channels that are available. And then I'm just going to introduce briefly information about the research facility. And then we'll go through the directory structure on the system and how we use software containers to manage software stacks. We'll go through how you access the different services that we offer. And then we'll talk about those services in more depth, specifically Jupyter, the notebook web interface, and then the actual cluster, which most people use, and how to submit jobs on the cluster. And then we'll talk about data transfers, and we'll end off with best practices. So I'm going to speak about the first sections up until Jupyter, and then Jordan's going to take over and give a training on SLURM, data transfers, and best practices. So in terms of the support channels and where to find information about the ilifu services, you can email the support team at support@ilifu.ac.za. So this is a ticketing system, and it allows for our support team, well, your email goes through the ticketing system, and we have a support team that will respond to your questions or issues that you might have related to the cluster. So that's the primary point of contact for us. We also have user documentation at docs.ilifu.ac.za. So I'm just going to show that website quickly. So this is the user documentation landing page, and we have a couple of do's and don'ts, just briefly indicating on how to use the cluster. And then the documents are broken down into a getting started section, which is a step-by-step guide on how to request access to the cluster, how to use the different services, how to change your password. It has information about how the structure, the directory structure of the cluster is laid out, and then information about software, how to submit jobs on the cluster, and it just takes you through a step-by-step guide in terms of you making use of the cluster. And then this section is followed by topics that are domain specific. So for example, astronomy has astronomy information about different software, as well as how to transfer data from the Surveyor archive. There is bioinformatics specific software related to the CBio group. And then the other topics are slightly more expanded information. There's also topics on how to transfer data to and from the cluster, as well as internally on the cluster. So these are a great reference for users. We do update these documents quite regularly and expand on topics where we see where we haven't covered enough information. So we do suggest that users often refer to the user documentation for help. We also have a new service, which is our ilifu systems status page. So this provides information about the current state of the cluster, and it can be accessed via status.ilifu.ac.za. So this provides, the top is the green bar, will just indicate whether the health of the system and all services operational. It has information about support, and then you can drill down into different individual services, and the indicator light will show if there is an issue and about specific services. So this is also a great tool for users to go and check. First, if they're having a problem, it may be indicated on the status page. And if it's not, we do request that you contact us through the support@ilifu.ac.za contact email address. Just to mention that these previous training videos are available on the ilifu website under the training tab. And it also has the presentations, the actual PowerPoint documents from the previous training video. And we are recording this training video, and we will put it up on the same website. And we'll subsequently release the advanced topics in the same way. Sorry, going back. Okay, so in terms of the research facility, we support a variety of different projects, particularly within the astronomy and bioinformatics fields. And these projects obviously have various requirements. So in order to support these projects, we offer both data management in the form of storage and data transfer services, as well as a flexible environment to meet the needs of the different projects. So in order to support the variety of different projects, to achieve this flexibility, we offer a number of different services. So the primary compute service that users will use is the SLURM cluster and SLURM job scheduler. So what this service provides a pool of resources available to all users, and users will submit their jobs, whether it's a script or workflow, or you want to run a pipeline. You submit this job to the SLURM job scheduler. The job will then be placed in a queue and assigned resources once those resources become available. The services that we offer is the JupyterHub service, which has a Jupyter Notebook web interface for development. And then we also, all the software on our cluster, we place inside containers, specifically Singularity containers. These are encapsulated software stacks, so they're separated from the operating system, but I'll go into more detail about this later in the training session. And then we also offer a number of data transfer services and software such as Carter, which is an astronomy visualization software. In terms of making use of the services that we offer, in general, users will interact with the facilities in two ways. Firstly, through the terminal. So you'll use the terminal to SSH into the login node of the SLURM cluster. The command is listed under the terminal image, so it's SSH and then your username at slurm.ilifu.ac.za. So this will connect you onto the cluster login node. And then the other interface that generally users will use will be the JupyterHub. So this is accessed through a web browser, and the the access web page is at https and then jupyter.ilifu.ac.za. So in order to navigate the storage and different directory spaces in the cluster, I wanted to briefly go through the directory structure. I think this is really useful and can be a bit confusing for users. So there are a couple of common areas, such as the user's home directory at /users, once you get into the cluster. And then another common area is the Scratch space, and each user will have a folder in /users and a folder at Scratch /users. So in terms of the user space, this space is only 40 terabytes, and it's shared amongst all users on the system. And so we recommend that this space is only used for scripts and small files. We request that users do not place data in their home directory. If this storage, because it's only 40 terabytes, if it's maxed out by a user, it can prevent access to the cluster for all other users. So this is quite a key issue. So do not place large data files in your home directory. The space is really just for scripts and information and notes that you might have in the cluster. So in terms of the Scratch mount, this is high performance storage, and it's a space dedicated for data processing. So each user will have a folder at /scratch/users where you can run your jobs and write output to. But this is a temporary storage space only. This space is a Scratch space. What this means is that you should only have data and large files here while your job is running, basically during data processing. So once your job is complete, you need to remove your data and output products out of your Scratch directory into other directories, which I'll explain shortly. So we also ideally recommend that users delete or remove intermediary data products as from part of the pipeline or job that you're running. So don't move unnecessary data to other storage locations, rather delete data that you don't need to save your time and also valuable resources. And so just a reminder to please clear your Scratch space after data processing. The remainder of the storage is divided up into work groups. So a number of groups that we currently host is the IDIA astronomy group, the bioinformatics group, and then we have another number of projects through the DERISA proposals, which fall under ilifu. So the structure for these group directories is generally the same across the different groups. So for IDIA users, they'll have a user directory at /IDIA/users. This is a user's kind of workspace. So what you can do is the output or data products from your processing can be stored at in this user space. So this is different to your home directory. It's on a different storage mount. I'll indicate that during the demo later. But so generally you'd want to put final data products in your project space to share with other members. But if you have intermediate stage of development, you can use the IDIA users as your personal workspace. So then next is each project has a project directory, which you'll find at /IDIA projects or /CBio projects. And these are directory spaces where you can place information, software, and outputs from your data processing that you want to share with group members. So this is a shared space. All members of a specific project will have access to this directory. And then in addition to that, for astronomy-specific projects, the Sorare archive data, which is pushed from the Sorare archive, will be made available from the individual project directories. And this data will be read-only. So you won't be able to adjust the raw data. You'll have to copy it or read from the data during processing in order to use it. And then we also have directories at IDIA software and IDIA software containers. So software can be found at this location, and all the containers are stored at IDIA software containers. So as I mentioned, similarly for the other groups such as CBio and ilifu, CBio users will have a directory at CBio/users, and different projects can be found the project folder for CBio. Similar case for the ilifu projects. The only difference is that the projects are specific, broken down into Astro and Bio as the following directories /ilifu/Astro/projects. I think that's all I wanted to say at the moment about the directory structure. I'll do a demo of that towards the end of the presentation. So as I mentioned about software stacks, on the cluster, we place all our software inside Singularity containers. These are very similar to Docker containers, except they have some benefits in terms of science workflows and security and using them on a cluster environment. So how this works is that everything that is required for a particular project work group or a pipeline is incorporated inside a container. And so all the binary files, the libraries that are required for the software, the environmental variables that are set in order to run the software, these are all built inside a container. And then a user will access this container in order to access the software, or he'll submit jobs on the cluster using the container which provides the software. So the benefit of this is that the containers can separate the underlying operating system from the software. So you could say install an older version of Linux in the container to allow you to use legacy software. And it also allows for software to be shared amongst group members if it's a project-specific container or other users on the system. So this is a really important point in terms of flexibility of the environment on the cluster. And then there's just an image at the bottom showing you like a visualization of container with a number of astronomy software packages using a Linux environment. So we do have pre-built containers. Majority of these are astronomy software that I generally support. So we have, for example, the Casa NRAO software for radio astronomy data reduction. And then we have Python containers. The source binding or astronomy container AstroPy is filled with all possible astronomy software packages and Python libraries applicable to astronomy. And then we have some base Python containers in our container. And then we offer support for different projects. We'll build specific containers for a project where they need particular software stacks. And then the containers are generally available from /IDIA/software containers, or for the ilifu projects specific or containers specifically to them is at ilifu software containers. So if you can't find what you're looking for in terms of the containers, you're welcome to contact the support team. We can either point you to where the software is already available, or we can provide you support in terms of building a container for your needs. I'm just going to show the documentation regarding the containers quickly, because I feel like it's useful information. So under supported software environments, the available containers. So here, for example, the AstroPy source finding container, these arrows are drop-down menus, and they provide information about packages and libraries inside the container. It's not a full comprehensive list of all the containers available. These are just the original containers that we mainly support. So the project containers are not shown here. But here you can see all the Python libraries and the astronomy packages related to the source finding container. All right. So in terms of using the Singularity containers, where you would normally just run software on your operating system. So what you do in terms of containers is that you have to invoke the container to use the software. So there are a number of ways to do this, but the primary two useful ways is to open the container environment as a shell environment using the shell command. So an example here would be Singularity from the terminal, Singularity shell, and then the path to the container. So this will place you inside the container, and you'll be able to look at the software or run the software inside the container. So that's more of an interactive space. So as an example here, Singularity shell, and then the path to the AstroPy container. So then from inside there, you could call Python if you were going to develop from the terminal command line, etc. And then the other way is to directly execute a script or software using the container. So this is useful when you submit jobs to the SLURM cluster. Jordan will go into this further, but what you would do is you would call Singularity, you would use the exec command, you would point to the container, path to the container, you would select a particular software, and you would provide the input parameters or scripts to that software, and this would be the job that you would submit to the cluster. So here an example is Singularity exec, and that's IDIA software containers, Casa stable, so this is a recent stable release of Casa software. You would call the software named Casa, and you would pass in your script, which may call a number of functions with parameters using the Casa software. Finally, I just want to point out the service. We'll do this in a demo, but this is just a reminder, this is the web address, so access through a web browser for the Jupyter web platform, and provides Jupyter notebooks. This is useful for a development space if you're preparing code, or you want to test out a pipeline prior to submitting jobs. And I'll do an actual demo of this service specifically. So I just first actually wanted to show just logging in, basically accessing the cluster. So from a terminal, you would SSH, and then it's your username at slurm.ilifu.ac.za. This will place you on the SLURM login node, so you can see this from the command line prompt. And this is, all our virtual machines are based in Linux environment. You can see a message of the day with information about contact support channels and documentation and basic do's and don'ts. So as Linux, just I'm not sure in terms of your experience level, but some basic commands would be to show the present working directory. You could ls to list the contents of the directory where you're currently at. I'll just show you the different storage mounts. So df-h shows you the percentage used in terms of the mounts. So here is your users mount and the size, and this is the scratch mount. And then the other group mounts are shared across a larger storage space. So this is ilifu, IDIA, cbio, the three that I indicated before. And those will have user directories and project spaces at those mounts. So if you go to, you can see /users, and everyone has a user folder here. So this is your home directory, and this is the one that has a small storage, only 40 terabytes in size. So best to only place small files and scripts here. And then at scratch users, you'll have a, scratch users. All users will also have a space here. So this is where you can do your data processing. And then just in terms of your working directory for IDIA, it'll be at IDIA users. For ilifu, all the ilifu users will have a folder at this point. And so this is your workspace, or your active work environment, and you can place data output at this location. And then just in terms of the projects, IDIA projects here, sorry, I'm being a terrible Linux user. IDIA projects, just to indicate these are all the astronomy projects under IDIA currently. So these are shared spaces for these individual projects, and similarly will exist for ilifu and CBio. And then lastly, in terms of the terminal environment, IDIA software containers. So if you view these, you can see all the different containers. The containers are kind of structured. The likely ones here are symlinks, and they point to the most recent development of that container. And you can see that previous versions of the container are available if you need to go back, or if you find that something that you're using is maybe currently not working in the container. So this is the containers that you would point to run different software stacks. Okay, and then just wanted to go to demo the JupyterHub interface. So a lot of people tend to have a lot of experience with Jupyter notebooks. So the web page for access from your web browser is jupyter.ilifu.ac.za, and this will bring you to a login page. So this is your username and password, the same username that you would have to access the ilifu cluster from the terminal. So you would sign in, and then this brings you to an option in terms of selecting your resources for the session. So it's a drop-down menu, and you can see it scales up into the different sizes. These are a number of CPU cores and the memory that's available and the length of time that your session will be active for. So we do request that users only utilize the number of resources that they require for their job. Please don't always go for the max node. So these are all, the underlying resources are shared resources, and it's best to only utilize what you need as opposed to hogging extra compute resources. So in this case, I'm just going to take the minimum node, and you click spawn to launch the session. So this is using a portion of the cluster's resources to provide you a Jupyter environment to use. So this will take you to the Jupyter Lab interface. This is the landing page. So here's your home directory. So /users /Jeremy, for example, here. And then this provides you different kernels. What these kernels are actually the Singularity software containers. These kernels utilize the Python packages inside those containers. So if you build your own container with different Python packages, you could potentially create a kernel and use your container as a kernel in this environment. So just in this example, you can start a new notebook using a Python kernel. This brings you to the standard Jupyter notebook environment, and you could go ahead and start coding in Python. I have an example notebook that I just wanted to demo. One of the a good point to note is that you can, once you're inside the Jupyter notebook, you are able to change the kernels by clicking on the kernel. You can select the different kernels that were available from the landing page. So you might find that different kernels have different Python packages that you may require. And then just as an example, script for Python. So a couple useful things inside a Jupyter notebook to make note of is that it does have an auto complete. If you press tab, you can find different functions related to a particular package, and if you use question mark afterwards, you can bring up the doc about that particular function, so you can see what parameters are required to be set here. And then also what should be noted is that you can run commands to the underlying operating system. So here, for example, I'm running the Linux command. This is the magic exclamation mark, and you can submit commands to the underlying operating system using this. For example, here I've done a pip freeze, which lists all the pip installed Python packages. So you can see this is the source finding or astronomy kernel, and it has a really large list of Python packages, and a lot of them are astronomy specific. Just a note about the Jupyter interface is that it also provides a terminal that you can use. So here, you're actually landing here, not on the login node, but you're in one of the compute nodes, which is where the resources are provided from for your Jupyter session. And you can see I'm in my user folder here, and I can go to my other, sorry, Jeremy, work directory. You can change your password here. For example, this is the password for logging into the system. So you're able to, and we do advise this once you've received your password from the support team, to please do change your password. I'm not going to do that now. And I think the last thing I wanted to bring to everyone's attention is that once you have finished doing your development and you're signing off, we do request that users please relinquish the resources back into the resource pool. So what you have to do there is you have to close down your session. If you go File and Hub Control Panel, you can click on Stop My Server, and this will release your resources back into the pool. Because currently the default setting for the Jupyter sessions are 3 days, and we often find that users may code for 8 hours and then they forget to release their resources, and those resources are then held for 3 days without them going back. You can always restart your server. It does keep information about its current state available, so all the notebooks that you had open will automatically open again if you go back into the Jupyter space. So it's quite a useful development environment in that way. So here I'm going to stop my server, and I could start my server, choose a larger node if necessary. But yeah, please do, we do request that users do relinquish the resources when they're not using them. I think that's everything I wanted to cover. And there we go, you can see my server is no longer running. So I'm going to hand over to Jordan, who will continue with the training session. Thank you, everyone. I'll remain for questions after the session.
Thanks, Jeremy. So just an apology in advance that we'll probably go a little over. We'll do our best to allow enough time for questions, but we are a little behind. So Jeremy, can you just confirm you can see my slides there?
Yeah, I can.
Yet. And then can you also see these?
I can see the user documentation, yeah.
Cool, all right. I'm gonna see if this works. Is that presenter view or is that? Sorry, you're muted, I think. Is that presenter view or normal view?
We're seeing the notes at the moment, presenter view.
That's really annoying. Zoom haven't fixed this yet. Anyway, so we'll just go ahead like this. It's supposed to grab the little screen down below. Anyway. So thanks, Jeremy. Just picking up from where he left off. Going to be covering SLURM and data transfers and best practices. So some of you might have been doing research long enough that you remember for any kind of data set that you might collect, you could download all your data to your laptop, you could process it there, you could visualize it there, and then perhaps you'd publish a paper about that. But the problem is that often the specifications aren't very good, particularly for newer data sets, which are dominated by large data rates. And so you want more storage, you want more CPUs, and you may even want to share your data amongst other collaborators. And so perhaps the solution is you could set up a server or some kind of virtual machine, a VM, and then multiple users can connect to this via SSH, a secure shell, and you could do heavy processing there with better specifications, including your memory and CPUs and storage. But then the problem is that you're actually sharing all of those resources with those users. So if someone's doing heavy processing using many CPUs and much memory, then if you also try and process data, then you're restricted to whatever's left over, which may actually be nothing. And so you actually, from there, the solution is to combine many machines together, many VMs together in what we would call a cluster. And then you also want to have some kind of resource manager, like what Jeremy mentioned before, SLURM, which schedules jobs that are allocated certain resources so that there's no kind of clash, but you're actually able to have sole access to those resources. So we'll talk in the advanced topics about how you might be able to use many machines at once for single processes, but for now we're going to be covering how you use the resource management software in order to run your jobs. So just to introduce ilifu, this is a tier 2 data intensive research facility. It's a joint cloud platform for astronomy and bioinformatics. It's one of these clusters with 96 nodes. So these are those individual machines or VMs or servers. Each of those has 32 cores or CPUs and between 256 or 512 gigabytes of memory. Between the different file systems that Jeremy was talking about, we have about 2 petabytes usable storage, and we have very fast 10 gigabit a second network access for all research institutions. And so SLURM is this job submission and resource management software that we use. And at the docs, you can read how to use that. You've got several examples and the syntax that you use for that. And so we have a login node, which is where you land when you SSH into the SLURM cluster. And this is where you should submit your jobs, but you shouldn't run your software or heavy processes on the login node. We might also call this the head node, but it's only to manage the job submission. Where you want to run your processes is on a compute node, also known as a worker node, and this is where the job gets sent from the login node. And so you do this using the commands we'll talk about a bit later, but essentially we have different partitions. The main one has 79 nodes, and each of those, within that partition we have a number of different compute nodes. We also have a partition for Jupyter, which Jeremy demonstrated. So the Jupyter spawner itself has its resources allocated within SLURM in a Jupyter spawner partition. And only on the compute nodes is Singularity available in order to run your software within the containers. It's not available on the login node, since you're not supposed to run your processing there, since this is just for submitting jobs, and all users are on the login node when they're submitting jobs via SLURM. And so you would SSH in, as Jeremy showed before, or you can connect to Jupyter at that URL. In addition to the main partition, we have a high memory partition. So this is where you can get up to almost 512 gigabytes of memory allocated for heavier processing. We also have a GPU partition as well. And so I'll demonstrate a little bit later these commands, but just to mention them first. So sinfo shows the partitions and it shows the resources that are available within those, as well as those that are being used. SQ shows all the jobs submitted to the SLURM queue. So to remind you, the queue includes jobs that are running, as well as ones that have been submitted to be run and will be run once the resources are available to you. You can also specifically show your jobs with SQ option U and then your username. You can submit one of these batch jobs, which I'll show later, using sbatch and then the name of your job script. Or you can pull up the help with option help. If you need to cancel a job that you've submitted, if something was wrong with it, or if you for some reason have to cancel it, you can use scancel and then the job ID. The job ID you're given when you run the sbatch job, and then saccount shows you the status of jobs that are either running or that have run, such as the completion status, whether it failed or completed successfully, and the exit code. So here's an example of a SBatch script, and so we might cat the script name, so this just prints the contents of it. So we have what we call the hash bang up the top, which is just to show that we're using bash, which was what Jeremy showed before with the ls and cd and such commands. And these are our SBatch parameters that describe the job and the resources that we might be requesting. So we give it a name, and this is what will be shown in the queue. We give it a wall time, so this just means the real time that you expect it to run within. And if it goes over, it'll get killed. And we distinguish this from the CPU time, which might be a much larger number if you're using more than one CPU. We also have the memory. In this case, I'm asking for 4 GB. So again, if I go above that, it will kill the job. And then I have a standard out and a standard error. Normally, both of these are printed to your terminal, but they're actually 2 different streams. And so in this case, the normal output will go to this file, and the %J just means the job ID will be written to the file name. And then this is the standard error, which is any problematic output to do with errors is written to that file. And then I'm specifying my account here, which we can cover in more detail in the advanced topics. And then I just echo or print submitting demo SLURM job. I call Singularity exec, so I'm executing this container. I'm running this software Python, and I'm running a script that I've written, my script.py. And so this is the contents of my SBatch file, and then I'll run that with SBatch and the name of the script, and this submits it to the queue. But I could put anything in here, so I could switch, to a different container, different software casa, and a different script. We can also run an interactive job. So again, documentation exists for this, how to do it with and without X11 support for forwarding X windows for some kind of GUI or something like that. So the simplest way to do this is srun pty, which is a pseudo terminal. It just means put you on the compute node, and then bash. So this will just open a bash session, but with the default parameters, which turns out to be a 3-day wall time and about 7 GB of memory. Or we could specify a shorter wall time of 1 hour in this case, and a higher amount of memory, and we could run Singularity and some kind of software there. And you can pull up the help with option help here. I apologize, this should also have PTY since I'm wanting to land on the compute node and interactively use casa. Now you can also connect to the compute nodes with X forwarding. And so to do this, sometimes you have to, on your own local machine, your laptop or desktop, SSH add option K, uppercase or lowercase. Uppercase for Mac OS X, lowercase for Linux. And this, we can talk about this in the advanced topics, but this is just something that you need to do sometimes, particularly if you've copied over an old SSH key from an old machine in order to be able to do X forwarding. And then you SSH in using options YA. Again, we can cover this in the advanced topics. You would then run salloc, and this will, again, put you on a compute node with the default arguments, but with X11 support. Or you could, if you want to increase the likelihood of your job running immediately, then you could pass in parameters like this. So a lower wall time than 3 days, a lower memory than 7 GB, and this would increase the likelihood of you getting an immediate job accessing the compute node. And then also QoS interactive. This is the quality of service. So you're saying, I want an interactive job. So that has a higher priority of going onto the compute node. All right, so let me demonstrate this. Jeremy showed logging in before and so on. So I'll just pick up from there. So in this directory, I've got some scripts just to demo the different SLURM commands. I might just increase this size here. So I'd start with sinfo. So this shows me the partitions and the resources available. So for instance, we can see here in the main partition, there's 45 nodes that are idle. That means none of their resources are being used. And so they're available to anyone who wants to submit jobs. And so I could start with srun pty bash. And this is going to put me on the compute node. You can see the prompt here now says SLURM worker 149 as opposed to SLURM login. So now I'm on the compute node, and I could, for instance, run Python myscript2. This literally just says hello from the container. In fact, it's not even inside the container for this script because I'm not using my sbatch file here. But this is just a quick demonstration to show you how I might be able to run an interactive session. Say that I wanted to run that without actually connecting to, without directly going onto the compute node with my session. I could just say srun Python myscript2, and so that allocates me the resources from that compute node and runs my process, but it doesn't place my bash session itself there. And so I just, I'm able to see the output, but I don't actually interactively with my session land on the compute node. And so this is okay, but it's even better to run processes with an sbash, for instance, so that you don't just have all the output printed to your terminal, but to log files. Let me also demonstrate salloc. And so this is a similar way to land on the compute node to running srun pty bash. So now you can see I'm on the compute node SLURM worker 149. And from here, I can run Singularity. So I could run Singularity shell, say IDIA, software, containers, Casa, stable. This is something I often use. And so I could do that. And from here, I could launch Casa. And you will see that this will enable X forwarding for the Casa logger, which is what comes up by default, showing you about the processes you're running and any relevant logs and output. And so that's what we can do with salloc, placing us on the compute node. Now I can also run sbatch. So this is my sbatch script that I showed before. So it's running just this Python script using this container by Singularity. And so just to show you this one. So this just prints hello from the container and then sleeps for 30 seconds. And you can also see within the sbatch job I echo submitting demo job. So I can run sbatch SLURM job script, and then you can see now I've got these output logs. And so one for standard error and one for standard out. If we look at standard out, you can see it's got that echo from the sbatch job and nothing else yet. I can now run sq, option u jfolia, so my username, you can see my job's in the queue, and then presumably by now-ish, it should be finished. Okay, still going for some reason. Okay, now it's finished. And so now I can look at the standard out. You can see it's got hello from the container. And this is what we printed from within the Python script. And then I can run s account, and you can see the recent jobs I've been running. You can see they all completed successfully. Here's an earlier one just to show you the failed status. So this is when something went wrong with it. And you can see the exit codes as well. And then just to show you that there was nothing written to standard error in this case, which is good. So I believe that's what I was going to demonstrate for for the demo, and we'll do more of that in the advanced training, but in more detail, like using many cores, using many nodes, and the advanced parameters that you can set. But for now, moving on to data transfers. So Jeremy mentioned some of these. This is all documented within the URL Jeremy showed. So again, just to reiterate, please don't use the SLURM login node to do data transfers. And please don't write large files to your user directory, only scripts and config files, since this is very limited in its storage volume. You use the transfer node, transfer.ilifu.ac.za. You can SSH here and move files internally, like CP or move or rsync between different file systems on ilifu. And you can also SCP and rsync externally. So for instance, this syntax, if you've got something on your machine, on your laptop or desktop that you want to copy over to ilifu, you would use SCP, the path to the file, and your username at transfer.ilifu, and then the path on ilifu that you want to transfer to. But for more frequent and larger transfers, you should use Globus, which is faster than these, and it uses a dedicated data transfer node. I don't need to go into a lot of detail here, but essentially it's quite user-friendly. It has a web app, or if you do want to automate it, it's got a command line interface. You can connect any arbitrary endpoint, so you could connect your own desktop or laptop. It's got apps for Mac OS X, Windows, and Linux. And so, but in the background, it's using Grid FTP, which is a very efficient transfer protocol. And so it's quite cool because it's a user-friendly tool, but an efficient transfer service. So in the advanced topics, again, we'll demonstrate this and how to do it. But for now, you can look at the docs. We also have this Arrayo archive. This is what it looks like. So for any, so this is astronomy specific for Meerkat data. And this is for any astronomer that's part of a project for Meerkat. If given permission by the PI, they can access the archive and the data from that project. But they must have an existing ilifu project, so you could contact our support email to request such a project. And this is all within the documentation, exactly how to do this process. So just to finish with our best practices, please don't run software or heavy processing or transferring on the SLURM login node. Only submit jobs to the queue from here and run the SLURM commands. So like sbatch to submit a job, srun to submit a job, and then the other things like sq, saccount, and so on to see the status of those. And then for transferring, use the transfer node, whether internally or externally to ilifu. Before running a large job, please identify the resources available. I showed you how to find that with sinfo. Don't hog the cluster. If it's possible to reduce your allocation, please do so. But we're also aware that some people require large footprints, and we can accommodate for that too. And again, if you use less memory and a smaller wall time, this is your time parameter, then you increase the likelihood of your jobs running immediately. Please use sbatch as much as possible, since srun, salloc, and maybe you know how to do screen or tmux sessions. These are quite volatile. And so if, for instance, we have to restart the login node, which happens from time to time, then these processes would be killed, whereas sbatch, which has gone to the compute node to run this process, they would not be killed. So it's much better to use sbatch. And there are other benefits like the log files that you get rather than needing to print to the screen. Please clean up files that aren't needed, such as old raw data, temporary data products, data in your Scratch file system. And please don't place large files in your home directory, your /users directory, since this is very small amount of storage. And please use Singularity, since you can't install software on the nodes. If you need software available within a container, please contact us and we can work with you on that. And again, Singularity is only available on the compute nodes, not the login node. So you can't run your processes there anyway. That's everything from me. Thanks for listening. I'm going to go to question time now. Sorry about the time. Hopefully we've still got enough time to cover your questions. So I guess for this, feel free to put the question in the chat or to unmute and ask your question. Does anyone want to kick us off?
Thank you for a great talk.
Hi, Javin. Thanks very much.
Yes, so I have a quick question. I've seen you've shown how to use different softwares and how to show, okay, you've shown the best practices. So I was also asking, can you next time try to show how to use R? Because I realized that the documentation on R is a bit confusing, and I think if you try to run R, normal R on ilifu, it doesn't go according to the documentation. But the R Studio seems to work. So can you next time please also try to show a demonstration how to run R on ilifu? Thank you.
Sure, absolutely, Shalin. I'll make a point of adding that into the advanced training workshop that we'll hold in 2 weeks. Thank you for the suggestion.
Hi, Joan. Sorry, I haven't checked your ticket lately. It's Dane here. So I saw that your R Studio was working now, I think, but I'm not sure what issue you're having with your R, but you can, I'll talk to you on the CBio Slack.
Yes, I did. I did change because I logged the ticket and I realized that the instruction that you gave, I followed and I was able to run the R Studio. But now,
Okay.
if you look at the documentation under bioinformatics stuff, the instruction is given there, but it doesn't work. So
Okay.
maybe that's what I'm requesting, if you guys can have a look at it. Because
Cool,
most
I'll
of my
check the
analysis I do
documentation.
on R.
Cool.
Yes.
Okay.
Thank you, John. I just want to point out that Ruth has asked in the chat, is it possible to get the slides? Yes, we will make the slides available. The information in the slides, all of it is in the user documentation, but the slides will be made available on the ilifu website at ilifu.ac.za, and there's the previous training video with the slides associated with that one is available there currently, but we will upload this video as well as the slides that we used to present to the website, and we will do the same for the next advanced training session. If there are any other questions, please feel free to ask, but you'll have to unmute yourself.
Hello, can you hear me?
Hi, Wisdom. Yeah, we can hear you.
All right, good. Thanks very much for this presentation. It's really an eye-opener. I have my data, which is sitting on a server at CBio at UC. So I need more computing power to do my analysis. So I've tried to rsync the data into my ilifu account. Using the rsync, I've tried a number of times. I've even used the SCP, but apparently when I do that and submit, it asks me for my password. I've entered my password like 3 times. Unfortunately, it rejects the password, but I'm able to use the passwords to log into my CBio servers and also log into my ilifu servers. So I don't know exactly what the issue might be. Maybe I'll use the support email and then probably to get a better assistance. But I think the presentation today is very great.
Sure. Thank you very much, Wisdom, for your comments. In terms of the rsync and SCP, I believe that they do use the SSH protocol, and sometimes users place a password on their SSH to their keys. So it may be a different password to the password used to log into the Jupyter services, for example. However, if this is if this is the case and you don't have the password, you may have to recreate your SSH keys and send them to us. But if you do send your issue to the support@ilifu.ac.za, and we will absolutely help you out.
Thank you very much. But I've actually used the same passwords for my CBio and then the ilifu. So I'm not too sure what the problem would be in terms of the password. But then, as you said, I use the support email, and then maybe you can discuss that further.
Okay, super. Thank you.
Yeah.
We have had another question in the chat from Patricia. Patricia asked if we can briefly explain how Nextflow works with Singularity and SBatch. Dan, I'm glad you are available, and I'm not sure if this is something we should include in the advanced topic in 2 weeks' time, but if you would like to provide some information now, you're welcome to.
I'm not going to be too helpful, I'm afraid. The best information I can talk about is Gerrit's documentation. So I think he's got quite extensive examples of how to get it going. So I haven't really run much Nextflow stuff myself. So I'll check with, I think just ask Gerrit where his documentation is. It's on GitHub somewhere. And I think as far as I know, it works quite well. And then if you're still having issues after following that, then yeah, please contact me. But I think it's a good idea to maybe add it to the advanced topics if there's time. But yeah, I'm not sure if it's general enough to fit into that program. But yeah, we can talk about it.
We do have some very specific astronomy topics, so it might be worth dividing it up into 2 sessions and doing an astronomy specific advanced topic and maybe a bioinformatics advanced topic where we can go over Nextflow use. Yeah. Thanks, Patricia. I'm just reading one of the questions in the chat.
Yeah, I've also read this. Thanks for the question about Stamella and running job array. This may be best to follow up with also a support ticket, but I'm wondering if so often when you run an array job, you limit the number of jobs that are running concurrently. So this is like after the percentage sign, you might say, you know, like 10, 20, so on jobs at once. So this should be basically running that many jobs at once across potentially multiple nodes. So when you're specifying that, then it should be able to do what you're wanting to do. But if there's more, yeah, that we need to consider there, then yeah, I think if we follow this up with the support ticket, we'd love to help you there.
Hi, Jordan.
Hi.
Yeah. So that was my question. Singularity. Yeah. So I do specify like a number of run at a time, but I've like tried even reducing it to 2 at a time, and I find that I just get one running, and then the other one would wait until that one is finished, and also so when I check on the on my SQ, I see that it allocates. So I specify like 5 nodes that I need to run 5 jobs at a time, and it specifies the same list of nodes for all of them. So then it waits, logs until I have to restart some of the jobs. And so I've had to restart some of them and then specify the actual nodes that are available.
Okay.
But I'm only running 64 of them right now, and I would need to scale this up to hundreds. and yeah, so I can't at that point like identify which ones are blocking and restart them. I'd like to know if there's a way to just specify that once maybe a node is available, then run the next job or something like that. I'll follow this up with an email and the ticket as
Sure,
well.
yeah, that is what's supposed to happen anyway. But yeah, if you submit a ticket and give us the syntax you're using and such, we can follow it up from there. And it might also be clearer when we present the advanced topics on how to run those kinds of jobs.
Yeah.
But in the meantime, we can chat to you over the support email.
Okay, I'll do that. Thanks.
There's another question from Javan. He's asked if we can comment on job splitting. Javan, do you mean specifically splitting jobs across multiple nodes or about job dependencies? Can you clarify your question? Okay, so with multiple nodes, this is a topic we're going to cover extensively in the advanced topic training session. We wanted to provide just the basics again for new users, but for multiple nodes, just a brief explanation. Any software running on multiple nodes has to be able to run with MPI so that information can be passed between nodes. So that's one of the requirements to split jobs across nodes. For example, I know that you're a bioinformatics background, but the Astronomy Kaiser software is built with MPI capabilities. So the only reason you would want to split across nodes is if the software caters for it. In this case, you would run the job, you would prefix the Singularity command with MPI run. And in addition to that, you would add, you would change the number of nodes greater than one. Jordan, do you have any further information
Yeah,
from your
so
experience?
I guess, as you say, we'll cover this extensively in 2 weeks in the advanced training. By default, most processors would use one node, one task, one CPU. If it's able to do CPU level parallelism with usually OpenMP, and you can specify multiple CPUs. But again, this is limited to one node, which only has 32. And so you could at most have 32 CPUs running if the software can handle that. And then as Jeremy says, beyond that, to use multiple nodes, you would then need MPI. There's other wrappers like AP run and things like that that you may use. But generally, it's only available for some software. And you can implement it yourself, but it's quite difficult. And so yeah, we'll cover this in the kinds of software and some worked examples in the advanced training.
Okay.
Just to note, there is R MPI, so you can definitely use R MPI, multiple nodes in R. But then it depends if the packages within there have been written with it in mind, or if you're writing your own stuff, then you can have a lot of fun with it. But it is quite a tricky package to use in my limited experience of R. Yeah.
Okay. If there are no other questions, I just want to say thank you for everyone for attending the session today, and also thank you for the support team for being here and presenting. If there are any other further questions, you're welcome to contact us at support@ilifu.ac.za, whether it's for an issue or if you just have questions about how to use the system. you're absolutely welcome to do that. And just a reminder that we'll do another training session in 2 weeks' time on more advanced topics. I think we have released a list of those topics, but we'll possibly expand on those topics based on the feedback from today's session. We may have to rope Dane into presenting some of the bioinformatics sections. Great. Thank you, everyone, for participating.
Thanks very much, everyone.
Thank you.
Thank you.
Thanks, Fangshir. Thank you.
Bye.
Bye-bye.